welcome back again. We're going to multiply scientific notation. You know how to multiply, you know scientific notation. We're just going to put those two ideas together to learn something new. Let's jump right into some examples and some understanding here. When we multiply numbers with the same base, so they have the same base and they both have exponents. We keep the base and add the exponent. So this is a little example here. 10 cubed is the same as saying 1,000, and 10 squared is 100. When you multiply those two, you end up with 100,000. Okay, so let's use our new knowledge. 10 cubed times 10 squared, keep the base, add the exponent, 10 to the 5th, that's also 100,000. So instead of working with all those zeros, we just use this new idea to shorten the process. So here's the first example. 1.2 times 10 to the 5th times 3 times 10 to the 7th. So we take the two numbers, the actual numbers, nothing to do with exponents, and we multiply those numbers just like normal. 3.6, keep the times 10, don't think we're multiplying the 10, just times 10 to the, add the exponents, and we get times 10 to the 12th, because 5 plus 7 is 12. So this is pretty simple, it's just you have to know how to do it. So multiply the numbers like normal, but when you get to the exponent part, keep the base, add the exponents. Let's go to that next example. 4 times 10 to the 6th and 3 times 10 to the 5th. We end up with 12 times 10 to the 11th. 4 times 3 is 12 times 10, and then 5 plus 6 is 11. But scientific notation can only have one whole number. You guys remember that? Hopefully you do. One number that's not past the decimal sign. This has 2, unfortunately. So 12 times 10 to the 11th, the decimal point is at the end. So we have to move it one place. For every one place we move to the left, we add 1 to the exponent. So it ends up being 1.2 times 10 to the 12th, because 11 plus 1 equals 12. So every time we have to move it over a place to the left, we add a number to the exponent. So it's not super difficult, it's just you have to know it. Same thing, well not the same thing here. Example 3 is going to be a little bit different because we have negatives. 2 times 3 is 6, that should be the easy part, times 10. And then we have a -5 and a -7. Those are the same signs. So we add the numbers and keep the sign. 5 plus 7 is 12. They're both negative. They're both going the negative direction. So -5 plus -7 is -12. And this is all set because it's just one whole number. Moving on to example 4, which is like the final boss because it's everything we could deal with. 5 times 7 is 35. Automatically, you should know that's not in the right form, but we're going to worry about it later because it's two whole numbers. Keep the times 10, and then we have 3 and -8, opposite signs. Remember, opposite signs, we find the difference. So the difference between 8 and 3, 8 minus 3 is 5, and then we keep the sign of the larger number, so we keep the -5. However, we have to move this over one place in order to make it proper form. So when we move it over to the left, we add 1. So once again, we have a negative and a positive number. So -5 and +1, well, the difference is 4. 5 minus 1 is 4. And then keep the sign of the larger number, which is negative. So that's as hard as it's going to get for you to have to deal with positive and negative numbers. If you struggle with that, we did make a card with all the steps on it. Hopefully you still have that. If not, you could look back in the book or ask me. I'll help you out. All right, thanks again for listening. Have a good day.